Good day ulit. Ourselves. So my name is Rashilin C. Berlan.
My name is Canelio Reyna.
And I am Hanin A. Bona.
And I am Enrique Piral.
And I am RV Maricao.
Cardinality of a set is the number of elements in a set. So let E be a set. So if E is not equal to empty set, then cardinality of A is 0. Then B, if A has exactly n elements in is a natural number, then the cardinality of E is n. Then the set E is a finite set. Then if otherwise, E is an infinite set. So the cardinality of a set of set A is denoted by this symbol. So letter A, if E is equal to empty set, then the cardinality of set A is equals to 0. B, if A has exactly n elements, then the cardinality of A is equals to n. Then C, if A is an infinite set, then the cardinality of A is equals to infinite. So, examples. So, to find the cardinality of a set, you just simply count the elements inside the set. For example, set A have these numbers 2, 3, 5, 7, 11, 13, 17, 19. So you just count those numbers and if how many that number, so that's the cardinality. For example, is 2, 3, 5, 7, 11, 13, 17, 19 is equals to it. So the cardinality of set A is 8.
So we proceed to the example number 2. Set A is equal to n, where n is a natural number, then the cardinality set of n is equal to infinity. Example number 3. Set A is equal to q, where q is denoted as rational number, then where the cardinality of q is equal to infinity. The last example is A is equal to 2n, where n is an integer. The cardinality set of A is equal to infinite, the set of even integers.
So let A and B be sets, then the cardinality of A is equal to cardinality of B if and only if there is 1-to-1 correspondence between the elements of A and the elements of B. So we have here an example. So the cardinality of A is equal to 1, 2, 3, 4, 5, while the cardinality of B is equal to A, E, I, O, U. So 1 corresponds to A, then 2 corresponds to E, then 3 corresponds to I, and 4 corresponds to O, and last is 5 corresponds to U. Then the cardinality of B is equals to 5. It is because A and B contains 5 elements in each set. So the second example is set A is equal to n, which n is denoted by the natural number, and set B is equal to the cardinality of 2n, where n is a natural number, the even number natural numbers. N implies 2n is 1-to-1 corresponds between A and B. Therefore, the cardinality of A is equal to cardinality of B. Therefore, B is equal to infinite. Set A is equal to n, which n is, as I said earlier, the natural numbers. Set C is equal to the cardinality of 2n minus 1, where n is a natural number, the odd natural numbers. N implies 2n minus 1 is 1-to-1 corresponds between A and C. Therefore, cardinality of A is equal to the cardinality of C. Then, cardinality of C is equals to infinite.
Countable and uncountable sets. A set S is finite if there is 1-to-1 correspondence between it and set 1, 2, 3, and so on and so forth for some natural numbers. A set S is countably infinite if there is 1-to-1 correspondence between it and the natural numbers. A set S is countable if it is either finite or countably infinite. A set is uncountable if it is not countable. Examples. The set 1 has 1, 2, 3, 4, 5, 6. Then the second set given has A, B, C, D, and so on and so forth. Our finite set A is equal to 7. A represents the first set, then the second set is 26. N, the natural numbers, Z, the integers, and the Q, the rational numbers, are countably infinite sets. That is, cardinality of Q is equal to cardinality of the integer equal to cardinality of N. The irrational numbers and the real numbers are uncountable sets. That is, cardinality of irrational numbers is greater than the cardinality of N, and the cardinality of the real numbers is greater than the cardinality of N.
To understand more about the cardinality of set, let's use the Helbert Grand Hotel. The question is, how can we accumulate a new guest arriving at the fully occupied Grand Hotel without removing any of the current guests? Solution is right in above. I'm going to read this. Because the room of the Grand Hotel are countable, we can test as the room 1, room 2, room 3, and so on. When a new guest arrives, we remove the guest in room 1 to room 2, the guest in room 2 to room 3, and the guest in room N to room N plus 1 for all one integer N. This piece of room 1, which we assign to new guests, and all the current guests will have room, illustrate this situation like that.